Namaste children. As I told in my previous video, we are going to start with the method of substitution, evaluation of definite integration by using substitution. No basics, nothing. Directly you know the method of substitution. We substitute that function whose differentiation is given along. ठीक है, हम लोग उस फंक्शन को पुट करने की कोशिश करते हैं जिसके साथ में डिफरेंशिएशन दे रखी हो, ताकि हम उसे इजीली इंटीग्रेट कर सके, उसको किसी ऐसे फॉर्म में कन्वर्ट कर सके जिसकी इंटीग्रेशन हमें आती हो. That is the target of substitution. You have done many questions by using substitution. Here also concept remains same. क्या extra? सिर्फ एक limits ही extra है ना? Doesn't matter. Is it clear? So method of substitution करते हुए limit भूल जाओ फिलहाल. है. मैंने टारगेट वही है, ये सोचना है कि किस फंक्शन को पुट किया जाए जिसकी डिफरेंशिएशन दे रखी है. अब cos की डिफरेंशिएशन sin होती है, sin की डिफरेंशिएशन cos होती है, बट cos की डिफरेंशिएशन में एक sin एडजस्ट होगा और पावर 3 है. Alright, clear? So what I substitute? And if you remember, we did if the even and odd powers of sin and cos, if both powers are odd, so I can substitute anything, answer will come. So those rules you will not forget. You have to practice. You have already practiced. You have done the questions. Presuming that you all remember indefinite integration, rules of indefinite integrations. Now, we have, so what I am going to substitute. So sin 2x is equals to t. What do? We differentiate both sides with respect to t. Sin 2x की differentiation cos 2x. Cos 2x की 2x की differentiation 2 dt. In differentiation I don't have 2, so that 2 will go that side. So it will become 1 by 2 dt. Clear? So my integral, right now I'm not writing a limit, I'll tell you what to do. Sin cube 2x would be written as t cube. Cos 2x dx is half dt. The half will go out. Now my question, which was in x, the limit was given for variable x. That variable x has been converted into t. Variable x has been converted into t. But my limits were in x. So limits were in x. Now the integral has come to t. So I can't use the same limits. Is it clear? So only this is the change. When you are changing one variable to other variable and the limits were given for this variable, now I have to change the limits also. I have to change the limits also. See how? Now this is here. First, as x approaches to 0, limits means as x approaches to 0, you have done the chapters of limits also. As x approaches to 0, सबसे पहले lower limit क्या है? X approaches to 0. यहाँ पर x को पुट कर दो. t का जो value आएगा वो lower limit बन जाएगा. Then what will happen? If I put, so when I put x is equals to 0, sin 0 is 0. So t also goes to 0. As x approaches to 0, t also approaches to 0. Simple क्या करना है? x की जो लिमिट है यहाँ पर पुट करनी है. उसके लिए जो t की वैल्यू आएगी वो लोअर लिमिट बन जाएगी. अपर लिमिट पुट करेंगे. x की वैल्यू, जो t की वैल्यू आएगी वो अपर लिमिट बन जाएगी. Now second, as x approaches to pi by 4, t will approach to, let's see, यहाँ पुट करते हैं. t is sin 2x. यहाँ पर पुट किया pi by 4, so it becomes sin pi by 2. What is sin pi by 2? 1. So that means as x approaches to pi by 4, t approaches to 1. As x approaches to pi by 4, t approaches to 1. Is it clear? So my limit has become from 0 to pi by 4, it has become 0 to 1. 0 to 1. That's it. Now we know the integration. Increase the power by 1 divided by increased power. Constant I am taking out. Upper limit 1 raised to power 4 would be 1, 0 raised to power 4 would be 0. So 1 by 8. Is it clear? So only this is the change. Substitution दिमाग वैसे चलाना जैसे हम पीछे चलाते आ रहे हैं. ठीक है. अब now when it changes to other variable, what do we have to do? The limit also changes. Because original limit was given for the original variable. When you are changing that variable into some other variable by substitution method, permanent substitution, is it clear? Then the limit also will change. So this you have to keep in mind. You will not go with the old limit, otherwise the question would be wrong. So we'll pick up more examples so that the things would be more clear to you all. See the second one. I had to integrate 5x raised to power 4 into under the root x raised to power 5 plus 1 from limit minus 1 to 1. From limit minus 1 to 1. Alright. So I know that directly I don't know the integration of this function. So who will help me? Substitution method will help me. Now what do we put in substitution method? Whose differentiation is given to us. And you have done lots of practice. By now you know what to substitute. So I am going to substitute this. X raised to power 5 plus 1. Differentiate. Alright, because the variable x is changing into t, so I'll change the limit also. As x approaches to, what is the limit first of all? Minus 1. T will approach to what? Put minus 1 here. Minus 1 raised to power 5. Minus 1 plus 1, 0. When x approaches to minus 1, t approaches to 0. As x approaches to 1, t approaches to what? 1 raised to power 5 would be 1, 1 plus 1 would be 2. Is it clear? So as x approaches to 1, t approaches to 2. Substitute now. Limit has become 0 to 2. 5x raised to power 4 dx, that has become dt. And this is d raised to power 1 by 2. T raised to power 1 by 2. That's it. This I know the integration. Increase the power by 1. Divided by increased power. And then I put the limit. This 3 by 2 can go out. Upper limit minus lower limit, 0 you substitute, you get 0. Alright, so it will be 8, 2, so it will be 2 root 2, so it will become 4 root 2 by 3. Understood? So this is the only change. Substitution method remains same. Whenever you substitute one variable to the other variable, you have to change the limit also. Clear? Now look at the next one. I have to integrate tan inverse x upon 1 plus x square with respect to x from the limit 0 to 1. Clear? So, clearly, very clearly can be seen from the question. I'll put tan inverse x. So now I have to change the variable limit also. As x approaches to 0. T will approach to what? I'll put 0 here. What is tan inverse 0? 0. So T will also 0, approach to 0. As x approaches to 1, T will approach to what? If I put 1 here, tan inverse 1. Tan inverse 1 is what? Tan inverse 1 is pi by 4. I hope you remember. Tan inverse 1 is pi by 4. So, limit has converted from 0 to pi by 4. This has become t. 1 upon 1 plus x squared into dx is dt. So integrate. Constant out. Zero. So it becomes pi squared 16 into 2, 32. Is it clear to everyone? So nothing new. Only thing is that you just have to be careful what to substitute. And when you are substituting, you have to change the limit. That is very, very important. Let's pick a few more questions. Then we'll be winding up this topic. Let's see the next question. I have to integrate 0 to 1 sine inverse 2x upon 1 plus x squared. As we have told you earlier, if you have an inverse trigonometry, simple if it is sine inverse and x, so you have to do it by parts. But right now, sine inverse has a bigger term. If you apply by parts right now, it will become very lengthy. Is it clear? You may not be able to come to the answer. So you know that you have done in inverse trigonometry, differentiation again I am repeating, and in integration also. Whenever you have inverse trigonometry and there is a bigger question in between, apply substitution according to the formula and then solve the question. Is it clear? So what I will substitute if I see sine inverse x? It is 2x upon 1 plus x squared. Alright, so I will apply substitution here, or directly if you know the formula I can apply of 2 tan inverse x. This is equals to 2 tan inverse x. So I can do by both. What do you want? Substitution or directly the formula? Because I know that this can be written as by inverse trigonometry. This is equals to 2 tan inverse x. Remember? this is equals to 2 tan inverse x. So I don't need substitution here. If you remember the formula, otherwise it will work with the substitution. What I put? X is equals to tan theta. Dx is equals to secant square theta d theta. The question will become, limit will change. Sine inverse 2 tan theta upon 1 plus tan square theta into secant square theta. ये किसका formula बनेगा? Sin 2 theta. Then sin inverse and sin 2 theta will get cancelled. So accordingly. Clear? So that's your choice. If you remember the sin inverse formula directly, so you can write it as 2 tan inverse x. Is it clear? Now it is 2 tan inverse x, and we know that to integrate inverse trigonometry we have to apply by parts. So let's solve it by parts. So this is my first function. Remember the word isolate? I told you, see, all the forms will come. It's not definite integration कर रहे हैं तो कुछ नए क्वेश्चंस आ जाएंगे. क्वेश्चंस would be all, कुछ भी आ सकता है. जितनी फॉर्म हमने अभी तक की हैं, कोई भी क्वेश्चन आ सकता है. पहले उसे नॉर्मल उस फॉर्म से सॉल्व करना है. लास्ट में सिर्फ लिमिट पुट करनी है. ये चेंज है. Is it clear? Alright. So I'll apply isolate. Inverse is the first step. So tan inverse x as it is. इंटीग्रेशन ऑफ 2 दैट विल बी 2x. अब ये वाला पार्ट इंटीग्रेट हो गया ना, तो इस पे लिमिट डाल देनी. ये ध्यान रखना. आप जस्ट टेक केयर ऑफ दिस थिंग. tan इनवर्स x हो गया. x की 2x की इंटीग्रेशन, 2 की इंटीग्रेशन 2x. नाउ बिकॉज दिस इज ओवर, सो यहां पर लिमिट यू हैव टू सब्स्टिट्यूट. क्लियर? नाउ साइन ऑफ इंटीग्रेशन, डिफरेंशिएशन ऑफ फर्स्ट फंक्शन. व्हाट इज द डिफरेंशिएशन ऑफ फर्स्ट फंक्शन? tan इनवर्स की डिफरेंशिएशन होती है 1 upon 1 plus x square into integration of second, that is 2x. Alright, so this part is already over. Here I can put upper limit minus lower limit. So upper limit is tan inverse 1 into 2, because 2 into 1 would be 2, minus 0 into something would be 0. Now we need to think what to do in this question. What is tan inverse 1? Tan inverse 1 is pi by 4. Is it clear? So this part is over. So girls, you have to take care. Suppose you have integrated this part. You have applied by parts. You have integrated this part. तो यहाँ पर लिमिट सब्स्टिट्यूट कर देनी है. छोड़ना नहीं है कि लिमिट आगे जाएंगे. यहाँ सब्स्टिट्यूट कर दो. Clear? Fine. Do not forget. अगर तुमने यहाँ पर इंटीग्रेट कर दिया और जल्दीबाजी में छोड़ दिया, तो the question would be wrong. Alright? Now this. अब ये कैसे होगा? Substitution. So I'll substitute. I'll just name it as I1. Clear? What I'll substitute? Put 1 plus x square is equals to t. 2x dx is equals to dt. That's already given to me. So my question has become this I1. Limit I'll be changing now. 2x dx is dt. 1 upon 1 plus x square has become t. What will be limit? As x approaches to 0. यहाँ 0 push किया. t will approach to 1. As x approaches to 1, यहाँ 1 push किया, 1 plus 1 would be 2, t will approach to 2. So my limit has become 1 to 2. Solve it. Log t, limit, upper limit, minus lower limit. What is the value of log 1? 0. So we have that's my answer. Is it clear? So we could do this question in two ways. Either directly substitution. Here I'll put x is equals to tan theta. तुम्हें पता है tan theta क्यों put करना है? Because it will become 2 tan theta upon 1 plus tan square theta. किसका formula? Sin 2 theta का. और sin inverse and sin will cancel. 2 theta बचेगा. Is it clear? And secant square साथ में, तो by parts वहाँ भी करना पड़ता, by parts यहाँ भी करना पड़ रहा है. Alright, and the substitution will also be covered. So that's your choice, girls. If you remember the formulas, all formulas, the question becomes very, very easy, and quickly you will be able to think about the questions. See the fifth example. I had to integrate x tan inverse x upon 1 plus x square raised to power 3 by 2 with respect to x from the limit 0 to 1. Clear? Now definitely such a big question without substitution will not work. So I have to substitute. So what I'm going to substitute? Just make it more clear, so I'll make it taking this tan that side. Clear? So now differentiate. Dx tan is secant square t dt. Limit also. As x approaches to 0, if I put here tan inverse 0 would be t, so t also approaches to 0. As x approaches to 1, t will approach to tan inverse 1 is pi by 4. Clear? That's for sure we know. Tan inverse 0, 0, tan inverse 1 is pi by 4. So my limit has become now 0 to pi by 4. Ab x का value tan g. Fine. dx क्या है? dx is, पहले ये लिख लेते हैं, dx is secant square t dt. tan inverse x is t and x is tan t. पहले x की वैल्यू पूछ की, tan t. tan inverse x is t and dx is secant square t dt. अब नीचे tan की वैल्यू, दिस x की वैल्यू tan. So tan square t raised to power 3 by 2. What is tan square t? Tan square t is secant square. 1 plus tan square t is secant square. So this is secant square raised to power 3 by 2. 2 and 2 cancel, so secant cube t. This is secant square. Clear? Cancel. Now just solve it later. I can write this tan as sine upon cos and this secant as 1 by cos. Cos and cos cancel. So what I'm left with? I'm left with 0 to pi by 4 t sine t. 0 to pi by 4 t sine t. Clear? So simplification is required, beta. Now how to go about it? By parts, you know that we have a word ilet. Trigonometry, ilet. Here, algebraic here. So algebraic would be treated as first function. So first function as it is, integration of sine. What is integration of sine? Minus cos t. The moment you integrate, apply by parts here, the limit should come. Minus sign of integration. So limit will come as it is. Differentiation of first. What is first function t? What is the differentiation of t? 1. And integration of second. Cosine integration minus cos t. So this will become. Here you can put the limits. Upper limit minus lower limit. Minus already है तो plus हो जाएगा. 0 into something would be 0. Because t की जगह 0 कुछ होगा तो 0 into something would be 0. Now integration of cos. We know that is sin t. 0 to pi by 4. Put the values. What is cos pi by 4? 1 by root 2. Upper limit minus lower limit. What is sin pi by 4? That is 1 by root 2 and sin 0 is 0. So I just can take this root 2 out. So it will be written as 1 minus pi by 4. LCM you want, you can take LCM also. Is this clear, children? So integration, you have to do it the way you have done in your previous indefinite integration, and towards end you have to apply, put the limit. The substitution method, the only thing what you have to remember, that is if you are applying substitution, you are changing one variable to other variable, your limit should also change. Clear? Fine. Let's look at the last question here. Which form? Latest we did it. 1 upon a plus b cos x. What we used to do in this? This is not by substitution. Directly any form can come. What we used to do? Constant will be written as cos square x by 2 plus sin square x by 2. Not here substitution, later on. Cos will be written as cos square x by 2 minus sin square x by 2, doubles formula. We'll collect the terms containing cos square and sin square. Cos square plus sin square, that becomes 4 sin square minus 5 sin square minus sin square. What was the next step? We had to divide numerator and denominator by cos square. Latest we have done this form. Divide numerator and denominator by cos square. It becomes secant square x by 2. 4 minus 9 minus sin square by cos square tan square. What was the next step? Put tan x by 2 as t. It becomes secant square x by 2, 1 by 2 dx dt. This 2 we always used to take that side. Clear? Now the limit will also change. As x approaches to 0, t will approach to what? I'll put 0 here. Tan 0 is 0. 2 will also approach to 0. As x approaches to pi by 2, it is pi by 2. As x approaches to pi by 2, put here, if I in the place of x, I'll put pi by 2. Pi by 2 by 2 will become pi by 4. Tan pi by 4 is 1. So t will approach to 1. Clear? So now my question has become I secant square by x by 2 dx is 2 dt, so 2 I am taking out, upon 9 minus t square. Limit is 0 to 1. Can you tell me, children, which form it is? 1 upon a square minus x square. That's right, 1 upon a square minus x square. What is the integration? 1 by 2a log of a plus x upon a minus x. And we have to put the limit. Constant, I am keeping it outside. Upper limit, 1 if I put, so 4 by 2 minus, if I put 0, it will be 3 by 3. So it is 1 by 3 log 2 and log 1 is 0. Is it clear? So this is what you have to do. Nothing difficult. Again, I am telling you. In definite integration, you just have to integrate the function the way you have done previously, and then you have to put upper limit minus lower limit. Alright, but there are few questions which will come little on the higher level. There you have to apply some properties to solve those questions. Directly you may not be able to solve those questions. Is it clear? So we have some properties of definite integration that we will be covering in the next video. Alright, so properties of definite integration would be our next topic with examples.